Hello everyone, I'm Julia, and in this video I'm going to be taking the integral of cotangent x, cotangent squared x, and cotangent cube x. The integral of cotangent x dx is, well, we're going to change cotangent x into cosine x over sine x. Cotangent x is equal to cosine x over sine x, and we're going to use U Substitution rule for this. So we're going to set u is equal to sine x, which would give us the du, which would be cosine x dx. We're going to replace cosine x times dx with du, and sine x is the u, so just the integral of 1 over u du, and the integral of 1 over u is equal to ln absolute value of u plus the constant. And finally, if we substitute the u back in, which is sine x, we would be left with ln absolute value of sine x plus c. Now I'm going to be taking the integral of cotangent squared x dx. The first thing you want to do here is use the Pythagorean identities. We know that 1 plus cotangent squared x is equal to cosecant squared x. So if we solve for cotangent squared x, we would have cotangent squared x is equal to cosecant squared x minus 1. We're going to replace cosecant squared x minus 1 with cotangent squared x here. So this is equal to the integral of cosecant squared x minus 1 dx, and we know that the derivative of cotangent x is equal to negative cosecant squared x. So that means the integral of negative cosecant squared x is equal to cotangent x. But we have a positive instead of negative, so we would have negative cotangent x. And also the integral of negative 1 is equal to negative x. And don't forget to add the constant. That will be our answer for the integral of cotangent squared x dx. Now I'm going to be taking the integral of cotangent cubed x. We're going to separate the cotangent cube so that we would have the integral of cotangent x times cotangent squared x in dx. Using the Pythagorean identities, we're going to replace cotangent squared x with something else using the Pythagorean identities. So 1 plus cotangent squared x is equal to cosecant squared x. Solving for cotangent squared x, we would have cosecant squared x minus 1. So we're going to replace this with cotangent squared x, and we would get the integral of cotangent x times cosecant squared x minus 1. We're going to simplify this a little bit by multiplying, and we would get the integral of cotangent x times cosecant squared x minus cotangent x dx. Now we're going to we don't have to do it, but I'm going to be separating these two integrands so that we would have two different integrals. We're going to have the integral of cotangent x times cosecant squared x and minus the integral of cotangent x dx. I forgot the dx here, so I'm sorry. Now we know what the integral of cotangent x is, but we're going to have to use U substitution rule for the integral of cotangent x times cosecant squared x dx. Like I said, the derivative of cotangent x is equal to negative cosecant squared x, and so this is equal to negative, we're going to set u is equal to cotangent x, which would give us the du, which is the derivative of cotangent x, which is negative cosecant squared x dx. Multiply negative 1 on both sides, and we would have negative du is equal to positive cosecant squared x dx. Now this would be the integral of cotangent x is equal to u, and we replace cosecant squared x dx with negative du. So cotangent x, this is supposed to be u. And the integral of cotangent x is equal to, the integral of cotangent x is cosine x over sine x. And we're going to use U substitution rule, and we're going to set u is equal to sine x, which then du would be equal to cosine x dx. So that would give us minus ln absolute value of sine x plus the constant. Now we still have to take the integral of u and minus du, so if we do that, we would have, I'm going to actually write the answer on the top here. The integral of u, or negative u, I'm going to move the negative from here to here. The integral of negative u is equal to negative u squared over 2 plus c, but we already have the constant here, so we don't really have to write it again. And then we're going to substitute the u back, which is cotangent x. So that would give us negative cotangent squared x over 2. This would be the integral of negative u du. So I'll just write that clearly on the top here. Negative cotangent squared x divided by 2, and the minus ln absolute value of sine x plus the constant. Finally, we got the answer for the integral of cotangent cube x dx. Thank you for watching, everyone. I hope you guys learned something from this video. Solving for the integral of cotangent x, cotangent squared x, and also cotangent cube x. Have a great day.